Hello everyone, myself Srinivas, Associate Professor in SNU Academy. Today I am here to discuss an important topics of algorithm subject which are really required for ISRO examination point of view. Okay. So here if you see algorithm subject friends, the important topics, the first highest priority goes to sorting algorithms. Sorting algorithms. If you observe all PYQ questions starting from 2007 up to 2023 papers, you can see many questions came from sorting algorithms friends, okay. That is highest priority topic. In sorting algorithms, you need to study bubble sort, quick sort, insertion sort, selection sort, merge sort and then heap sort. And we have detailed plan for preparation of sorting algorithms. I will explain little later. Let me mention the topics which are having high priority topics in ST examination point of view. Okay. The first one is sorting algorithm and the second one spanning tree. Spanning tree. Where in the spanning tree we have to discuss Prim's algorithm and Kruskal's algorithm and also need to understand how to draw number of possible spanning tree for the given graph. Okay. And the third topic we need to focus on heap tree concept. It is also highest priority topic where they are frequently asking questions in this exam friends. Okay. After heap tree, then you have to focus on shortest path algorithms. Shortest path algorithms. So when we are talking about shortest path algorithms, we need to study Dijkstra's algorithm, Bellman-Ford algorithm and multi-stage graph and all pair shortest path algorithm which is Floyd-Warshall's algorithm, and also we need to cover unweighted graphs, like by using BFS algorithm we can find shortest path distance for unweighted graph. Clear friends, okay. We need to focus all those algorithms in shortest path algorithms, right? Okay. That is a fourth topic. After completion of fourth topic, then you can come to the topic of time complexity. Time complexity. Generally, these time complexity based questions have been classified into three categories, friends. Okay, three categories. Like we need to study time complexities for the programs which are having simple loops, and also we want to study time complexity for algorithm which are having nested loops. Okay. And third one, that is time complexity for recursive algorithms. Right friends, okay. This is the fifth priority topic, fifth highest priority topic in algorithm subject friends, okay. Next afterwards, sixth topic is asymptotic notations. Asymptotic notations. So we are having 5 types of asymptotic notations like big O, big omega, theta, little o and little omega. So we want to study all 5 asymptotic notations friends, okay. That is a sixth topic. And afterwards we need to enter into another topic is called greedy algorithms. Greedy algorithms. So in greedy algorithms, there are certain algorithms like job sequencing problem, knapsack problem, optimal merge pattern, Huffman encoding. So we need to focus all these 4 algorithms friends, okay. Then let me write down those algorithms. One is called job sequencing algorithm. Another one is optimal merge pattern. Optimal merge pattern. Next one, Huffman encoding. Huffman encoding. Next one, knapsack problems. Knapsack problems. Clear, friends? Okay. So these are the highest priority topics in algorithm subject. Remaining topics, like if you say dynamic programming, in dynamic programming we are having topics like longest common subsequence problem, matrix chain multiplications, right, and also 0-1 knapsack problem. So these are lowest priority topics. So if you have time, you can go through it. I can suggest you one topic that is called matrix chain multiplication algorithm, friends. Okay, that is most important topic. So therefore, 8th highest priority topic I can say matrix chain multiplication. Matrix chain multiplications. It is the 8th highest priority topic, friends. Okay. So when you start preparation for algorithm subject based on ISRO PYQ questions, first you have to give preference to sorting algorithms. Right, friends? Okay. Let me focus on what type of question they will ask in sorting algorithms. I hope you understand the workflow, right, friends? Okay. Then if you look at sorting algorithms, generally sorting algorithms we are having input elements either in ascending order or descending order, or it may be in the random order. So therefore, based on this input ordering elements, they are frequently asking the questions, friends. Okay. Therefore, the first model, assume that input elements are in ascending order. If input elements are in ascending order, input array elements in ascending order. If the input elements are already in ascending order, then how to find time complexity for each and every algorithm, friends. Okay. And the next one, if the input elements are in a descending order, array elements in descending order. Third case, where array elements are neither ascending order nor in descending order. Neither in ascending order nor in descending. So first input we have to classify in this way, friends. Okay. Now afterwards we need to study time complexities. So whenever I am talking about time complexity in sorting algorithm, you have to focus on how many number of comparisons are required and how many number of swappings are required for sorting the given array of n elements. Right, friends. Let me focus on bubble sort. See, bubble sort point of view, if input array elements are in ascending order, then they may ask questions like how many number of comparisons are required, how many number of comparisons are required, number of comparisons, and also they will ask number of swappings, how many number of swappings are required, and finally they will ask question is time complexity, comparisons, swapping and time complexity. Similarly, if array elements are in descending order, we need to find how many comparisons, how many swappings are there, and what is the time complexity. TC stands for time complexity. Right, friends. Okay. So here neither ascending order nor descending order. We need to find again number of comparisons, number of swaps, and you have to find time complexity also. Okay, time complexity. Let me fill one of them, friends, so that you will get a clear idea how to answer this type of questions. For example, if you consider quicksort algorithm, friends. Okay, quicksort algorithm, if array elements are in the ascending order, if array elements are in the ascending order, it takes worst case time complexity. Clear? If array elements are in ascending order, it takes worst case time complexity. Let me explain how it is taking worst case time complexity. For example, there are array of n elements. Assume that we are having array of n elements. Lower index I am taking P and upper index I am taking it as Q. Just you can take P comma Q, or you can say P comma R. Let us consider lower index of the array is P and upper index of the array is R. In general quicksort algorithm, we are taking last element as a pivot element, friends. Okay, last element as a pivot element. So suppose we are choosing last element as a pivot element. After choosing last element, we have to apply partitioning algorithm. What is the purpose of partitioning algorithm? The responsibility of partitioning algorithm is it will place pivot element in its proper place. Is it clear, friends? The responsibility of partitioning algorithm is it will place pivot element in the proper place of the array. Okay, so therefore we have to select last element as a pivot element. Assume that we are selecting last element and we are storing it into X. X is equal to pivot element, friends. Okay, where is pivot element? Simply I can say A of R. What is A here? A is the name of the array. Assume that name of the array is A and R is the last index of the array, friends. Okay, we are selecting that element as a pivot element. Afterwards, we are applying partitioning algorithm. Suppose this partitioning algorithm place this pivot element into proper place. Proper place means, for example, let us consider we are having elements like 50 and then 80, 60, let it be 40 and then 30. Let us consider it is 20. So let it be 45. Just assume, friends. Okay, total we are having 7 elements and I am choosing last element as a pivot element. After applying partitioning algorithm, this element must be placed in the correct place, friends. That element must be placed in the correct place. The correct place means, for example, see, if you apply partitioning algorithm on the given array, that partitioning algorithm will place 45 in its correct place. In its correct place. Let us assume that 45 placed in the correct place. But how do you ensure that 45 placed in the correct place? So by the time 45 is placed in this place, then left side values always smaller than pivot element and right side values always greater than pivot element. Then I can assume that I can assure that 45 is in the proper place. But to place 45 in the proper place, which algorithm we applied internally? Partitioning algorithm. Therefore, that partitioning algorithm will take time complexity is theta of n time. We can read from the notebook, you can understand. Okay, partitioning algorithm to place pivot element in the proper place, it takes theta of n time. Right, friends? Okay, so as a result of placing 45 in the middle position, then this array is splitting into 2 equal parts. Okay, this array is splitting into 2 equal parts. Suppose let us assume that number of elements in the array, there are n elements are there, and the time required for sorting n elements, I am defining it as something like T of n. Time required for sorting an element, I am defining it as T of n. Afterwards, as a result of placing pivot element in the proper place, the partitioning algorithm is taking how much time, friends? Theta of n time. Therefore, T of n is equal to theta of n. We place pivot element in the proper place. Afterwards, that array is divided into 2 equal parts, where left part contains at most n by 2 elements and right part contains at most n by 2 elements. Left part we are having at most n by 2 elements and right part also we are having at most n by 2 elements. If there are n elements are there, the time required for sorting n elements I am defining it as T of n. Now left part we are having only n by 2 elements, right? Therefore, the time required for sorting these n by 2 elements we can define it as T of n by 2. And time required for sorting these n by 2 elements we are defining it as T of n by 2. T of n by 2. Therefore, the total time complexity is equals to time required for sorting n elements equal T of n. After placing pivot element with theta of n time, that array has been divided into 2 equal parts, where left part contains n by 2 elements That's why it is taking T of n by 2. And right part contains n by 2 elements. That's why it is taking again T of n by 2. Right, friends? So therefore, if you solve this equation, 2 times of T of n by 2 plus theta of n, you can apply master theorem for solving this equation. You will get time complexity is theta of n log n. Theta of n log n. Now, if you observe, friends, input elements are neither in ascending order nor in the descending order. So, if array elements are neither in the ascending order nor in the descending order, then quicksort algorithm is taking theta of n log n time. Is it clear, friends? But we have 3 types of inputs, right? Ascending order, descending order, neither ascending nor descending. Let me check what will happen if array elements are in the ascending order. Okay. Let us consider there is an array having elements already in the ascending order, like let us consider 10, 20, 30, 40, 50 and then 70. Now, in general partitioning algorithm, means in general quicksort algorithm, which element we are selecting pivot element, friends? Last element. Now, choose last element as a pivot element. Choose last element as a pivot element. After choosing last element as pivot element, you have to place that pivot element in the proper place. That's why you are taking help of partitioning algorithm. Right, friends? Okay. That's why you are taking help of partitioning algorithm. So, if you apply partitioning algorithm and if you want to place this pivot element in the proper place for placing pivot element is this is the place where we can insert, right? Because all elements to the left side of 70 are smaller than 70. That is the reason I can say this is a place where we can place pivot element. Right, friends? Okay. But placing pivot element, which algorithm you applied? Partitioning algorithm. Therefore, partitioning algorithm will take time complexity is theta of n. After spending theta of n time, then array is having only left subarray which contains n minus 1 elements. Right, friends? Okay. Initially, your array contains how many elements? N elements. Then the time required for sorting n elements, we are defining mathematical equation T of n. T of n stands for time required for sorting n elements. Which element we are sorting first? We are sorting means we are placing pivot element. To place pivot element, which algorithm we are applying? Partitioning algorithm. So, partitioning algorithm, how much time it is spending? Theta of n time. Right, friends? Okay. So, therefore, I am taking theta of n time. After placing pivot element in the proper place, then your left subarray contains how many elements are in the left subarray, friends? This left subarray contains exactly n minus 1 elements are there. Now, to sort n minus 1 elements, the time required for this one is T of n minus 1. Right, friends? Okay. It is a time taken by partitioning algorithm and the required time to sort n minus 1 element is T of n minus 1. Again, you can apply master theorem. There is one shortcut method for solving this problem. You can apply master theorem. The shortcut method is, suppose if recurrence equation is a into T of n minus b plus theta of n to the power of k. Just assume that we are having recurrence equation in this format, and specifically if a is equal to 1, okay, if a is equal to 1, then we can write the solution for this one as T of n is equals to theta of n to the power of k plus 1. Theta of n to the power of k plus 1. In this example, friends, what is a value here? Just compare here, a is equal to 1. Right, friends? Obviously, in this case, we are taking b value also 1 because subtracting 1 at a time. So, therefore, I am taking b also 1. Okay, b also 1. So, therefore, theta of n to the power of k plus 1. What is k value, friends? K value equals to 1. Therefore, which is equals to theta of n to the power of 1 plus 1, which equal theta of n square. It means that we understood that if array elements are already in the ascending order, then quicksort takes theta of n square time. Whereas, if array elements are in the random order, it takes theta of n log n time. Is it clear, friends? Okay. Now, same logic you apply for array elements are descending order. Suppose if array elements are descending order, then array structure may be looking like this. Suppose we are having elements 80, 60, 50, 40, 30 and then 20. So these are the elements we are having, friends. Okay, we are selecting last element as a pivot element. We are selecting last element as a pivot element. Now after selecting last element pivot element, then you can apply partitioning algorithm. The partitioning algorithm responsibility is placing this pivot element in the proper place, like this. Okay, because array elements in the descending order, therefore last element must be in the first place, right, friends? Okay, if you want to arrange them in the ascending order. So placing that element in the proper place, we are using algorithm is called partitioning algorithm. The partitioning algorithm will take time compressed state of n. Afterwards, friends, this subarray, right subarray contains how many elements? N minus 1 elements. Suppose in the beginning if we have n elements, then the time required for sorting n elements is T of n, and we already spent theta of n time for placing pivot element in the proper place, therefore it is taking theta of n time. Afterwards, this right subarray will have n minus 1 elements. To sort these n minus 1 elements, we can spend time is T of n minus 1, right, friends? Again it is same as previous equation, therefore the time compressed after sorting this one, theta of n square. So final summary, if array elements are in the ascending order or array elements are in the descending order, then quicksort algorithm takes theta of n square time. If array elements in the random order, it takes theta of n log n time. Is it clear, friends? Okay, and here we need to focus on comparisons and swappings also, as I mentioned in the table. You can remember quicksort algorithm comparisons bounded by theta of n square if array elements are in the ascending order. Okay, even swappings also bounded by theta of n square if array in the ascending order, and time complexity is taking theta of n square only. It's better you can remember time complexity, friends. Okay, so from the time complexity you can easily understand comparisons and then swappings. Descending order also will have same concept, that is theta of n square, and then time complexity is theta of n square. Then what about neither ascending order nor descending order? In this case it takes comparisons are less, theta of n log n comparisons, and swappings also theta of n log n, and total time compression also theta of n log n. That's all. These are the three areas we need to focus, right, friends? Okay, then what type of applications are there in quicksort? What type of applications? Generally, friends, if you see that partitioning algorithm, if that partitioning algorithm we are selecting last element as a pivot element and we are placing pivot element in the middlemost position. If you place pivot in the middlemost position, that is known as median of the given array. You know what is a median, right? So median means first you have to arrange them in the ascending order and then you can pick up the middlemost element, that is called median. But here by using partitioning algorithm, fortunately if the last element is placed in the middle position with the time spending theta of n time, then we found median with only theta of n time. Generally median algorithm, friends, first you have to sort elements in the ascending order. Sorting itself takes minimum n log n time or maximum n square time. After sorting you have to pick up the middlemost element. Therefore finding median, in that case it takes n log n or n square. But if you apply this partitioning algorithm, fortunately the selected pivot element is placed in the middlemost position, we can find median with order of n time also. So that is one of the application. So there is algorithm is called selection algorithm. By using selection algorithm we can find median of an element is order of n times, friends. Okay, that is one algorithm. Clear, friends? Okay, and next one, in the PYQ papers, suppose if you observe PYQ papers, what type of question they ask in the exam based on quicksort? So T1 is the time required for sorting elements in the ascending order. For example, they provided input is 1, 2, 3 up to so on n minus 1 n. Array elements already in ascending order, and T2 is the time required for sorting elements in the ascending order, but array elements they provided like this: n, n minus 1, n minus 2, so on 3, 2, 1. Means they are saying that T1 is the time required for sorting this array and T2 is the time required for sorting this array, but both are taking quicksort algorithm only. Then they will ask the question, what is the relationship between T1 and T2? Okay, they may provide options like T1 greater than T2, T1 is equals to T2, T1 less than T2, third one, maybe they will assign some value like T1 is equal to something like T2 plus something 100 plus, like that they will provide some constant value. Okay. So generally friends, whenever array elements are in ascending order and array elements are descending order, then time remains same, that is theta of n square time friends. Okay, theta of n square time. So I can say T1 is equals to T2 friends. Okay, here it is a constant, we no need to give importance to the constant. Okay, so therefore T1 is equal to T2 plus 100 means they are talking about comparisons point of view. Comparison point of view, I cannot say T2 plus 100 equal to T1 friends. Okay, so therefore you can say T1 is equals to T2. Hope you understood, right friends? Okay. Similarly, if you see merge sort algorithm, merge sort algorithm irrespective of the ordering of elements, it always takes order of n log n only. Okay, merge sort algorithm, the time complexity irrespective of ordering of elements, it is always taking n log n. Then if it is n log n, how many comparisons are there? Means comparisons also n log n internally, and data movements also n log n. Movements are swapping. Generally we are using this word is swapping. Sometimes they are using data movements. Here we are applying data movements. Okay, when it comes to merge sort algorithm, we are taking data movements, data moves. Okay, is it clear friends? Okay, same thing we can fill up here also. Theta of n log n. Right, theta of n log n. Then what type of applications question they will ask based on merge sort algorithm? So there is one concept is called inversions. We can find inversions of the given array with the help of merge sort algorithm with the time complexity just theta of n log n. Just theta of n log n. Let me explain what is the meaning of inversions. When you are talking about inversion, suppose let us consider an array. Let us consider an array having elements like 1, 2, 3, 4 and then 5. Suppose elements are like 10, 50 and then 40, 20, let it be 60. If I ask how many inversions are there in the array, there is one definition for inversions. For I less than j, if a of I value greater than a of j, then we can say a of I comma a of j under inversion. A of I comma a of j under inversions. For example friends, here I is equals to 1, j is equal to, I am taking 1 less than 2, 1 less than 2. What about a of 1 value? Just look at a of 1 and a of 2. If 1 less than I less than j, a of I must be greater than a of j. Means I am expecting a of 1 must be greater than a of 2 I am expecting. But here a of 1 is 10, a of 2 is 20. So this condition fail. That's why these two are not under inversion. These two are not under inversion. Similarly, if I consider 50 and 40 friends, okay, 50 index is 2 and 40 index is 3. And we can say a of 2 is greater than a of 3. Yes. What is a of 2? 50. A of 3 means 40. So 50 greater than 40. That's why they are called under inversion. Clear friends? 2, 3 are under inversion. In order to find these inversions, we can take help of merge sort algorithm. Therefore, in the exam they may ask the question, what is the time complexity for finding number of inversion in an array of n elements? So I can say directly time complexity for finding number of inversions are theta of n log n. Theta of n log n. Is it clear friends? Okay. Next. See here I want to explain one more property, that is adaptive sorting algorithm. Sorting algorithm having certain characteristics. Adaptive sorting algorithm, in place sorting algorithm, stable sorting algorithm, like that. What is the meaning of adaptive sorting algorithm? Adaptive sorting algorithm means if the array is already pre-sorted, and pre-sortedness of the array affect the execution time, then that is called adaptive sorting algorithm. For example friends, here array is already pre-sorted, here time complexity is n log n, here also n log n, there also n log n. Even though array elements are pre-sorted, it does not affect the execution time. In such case, that algorithm is called non-adaptive sorting algorithm. So merge sort is non-adaptive sorting algorithm. What about quick sort friends? If the array elements are in the ascending order, it takes theta of n square, right friends? If the array elements are ascending order, theta of n square, descending order theta of n square, but in the random order neither increasing nor decreasing, takes n log n. So if the pre-sortedness of the array affect the execution time, then it is called adaptive sorting algorithm. So I can say adaptive sorting algorithms are quick sort is adaptive sorting algorithm, right friends? Quick sort is adaptive sorting algorithm, whereas merge sort is not adaptive sorting algorithm. What about insertion sort? What about insertion sort? Insertion sort friends, generally the time compressor of insertion sort, if the array elements are neither ascending order nor descending order, it takes theta of n plus d. The time complexity of insertion sort is theta of n plus d. What is n friends? N indicates number of elements in the array. What about d? D indicates number of inversions. So if the array elements are in the ascending order, you never get inversions. Then the time complexity becomes theta of n plus d. What is the value of d? 0. This is a time complexity. I am talking about time complexity. Here I have written time complexity is theta of n plus 0. Because if array elements are in ascending order, is it clear friends? If the array elements are in ascending order, then number of inversions becomes 0. We can say theta of n plus 0. Similarly, if array elements are descending order, yes, this time number of inversions bounded by n into n minus 1 by 2. N into n minus 1 by 2. If array elements are descending order, we have number of inversions are n into n minus 1 by 2. Here n square is a dominating value, that is the reason time complexity is, we can say theta of n square. Because when comparing to n square is dominating or not? Yes, that's why it is taking theta of n square. So this is called adaptive sorting algorithm. What do you mean by adaptive sorting algorithm? If array elements are already in the increasing order, then automatically it affect the execution time, that is called adaptive sorting algorithm friends, okay. So quick sort is adaptive, insertion sort also adaptive, but merge sort is non-adaptive sorting algorithm. Then insertion sort point of view, what type of application they are asking? If you look at the PYQ question friends, in the insertion sort, we are picking up the last key, we are picking up one key, right? We want to insert that key into sorted part of the array. That is the object of insertion sort. For example, let me take simple example, you get clear idea. The main object of insertion sort is, suppose we are having elements like 0, 1, 2, 3, 4, 5, 6. Let us consider array elements are 10, 20, 30, 40, 50, 60. Here let us consider some element, let it be 5, right friends, okay. So the main object of insertion sort is friends, some portion of the array is already sorted, So which portion of the array already sorted here, just observe. So this portion of the array already sorted. Then what is your responsibility? Your responsibility is pick up this key and place this key in its proper place among the sorted elements. Right friends, suppose this element whatever I am picking up, I am storing it into one variable is called key. Key is a variable, and in that key we are having 5 friends. Then how I can place 5 into the proper place? So let us assume that I is a variable, and j is a variable which is pointing to key index. J is a variable which is pointing to key index, whereas I is a variable, it is pointing to just before j. It is pointing to just before j. If suppose j equal to 6, I equal to j minus 1. Just imagine friends, okay? If j equal to 6 and I equal to j minus 1, then how can I place this 5 in its proper place? Very simple friends. As long as a of I value, means a of I value greater than key value, means we are comparing like this. Just observe, if a of I value greater than key value, as long as this condition is satisfied, then what you have to do, you can shift this element to the next location. You can shift that element to the next location. Is it clear friends? That means if this condition is satisfied, we are copying a of I element into a of I plus 1 location. That's what I am saying. If a of I greater than key, then simply shift a of I into a of I plus 1 location. After shifting, what you will do, decrement I by 1. I is equal to I minus 1. Right friends. Now again you can take, now I is pointing to which location? 4th location. Now again comparison, a of I greater than key. So 50 greater than 5, yes, 50 greater than 5. The moment 50 means I am taking comparisons like this. First comparison, 60 and 5. 60 greater than 5, true. Second comparison, 50 greater than key, yes, it is also true. Whenever it is true, you need to move that element to the next location like this. This is occupied by 50. So a of I copied into a of I plus 1. After decrement I by I minus 1. Yes, I am decrementing I by I minus 1. Then you can select 40. So 40 is going to compare with key. 40 greater than 5. Yes, 40 greater than 5. Then what you have to do, you can shift 40 to the next location by using this step, a of I plus 1 equal to a of I. After shifting, I decremented by 1, I is equal to 2. Right friends, okay? Next, take 30, compare with key. So I can say 30 greater than 5. 30 greater than 5, yes, true. True means shift 30 to the next location. After decrement I by I minus 1, so I is pointing to first index. Do the same process, 20 is going to compare with key. So 20 is going to compare with key, yes, 20 greater than 5. Then what you have to do friends, you have to shift 20 to the next location and decrement I by 1, I becomes 0. Right friends, I becomes 0. Now compare 10. 10 greater than 5, yes, true. 10 greater than 5, that is true. True means you have to shift you have to shift 10 to next location. You can decrement I by 1, I becomes minus 1. Is it clear? I becomes minus 1. If array is starting from 0, it is taking minus 1. Is it clear friends? Okay. It means how long we are shifting this process means, just look at here. As long as I greater than or equal to 0, I greater than or equal to 0 and a of I greater than key, as long as this condition is satisfied, means this is a while loop. This condition is satisfied, we are keep on shifting. Right friends. Once I becomes minus 1, this condition fail, it will come out of the while loop. Then you can copy key, whatever key is there. What is the key value friends? 5. You can copy that key. See, you already shifted this 30 here, you already shifted 20 here, you already shifted 10 here. Now this location is empty, that location is empty. But this location is pointing by whom? 0. Right now where is I? I equal to minus 1. That's why I want to shift again. I want to increment I value to this location. How to increment? Simply key is equal to a of I plus 1. That's it. Right friends. This is pseudocode of the insertion sort algorithm for inserting key into sorted part of the array. Like in real life example, you may be having a habit of playing cards. Okay. I'm sorry if you don't have. So assume that players, they are having cards in the left hand. Now whenever they pick up the new card, they are going to compare that new card number against the existing card numbers. Suppose if the new card number is greater than this card, then you have to simply move, and if this number is greater than this, you can simply move. If this card number is less than this and greater than this, and you can insert that key, means that card, right friends. So unknowingly we are applying insertion sort algorithm in while playing cards. Is it clear friends? Okay. Then applications point of view friends, observe, in order to find the location of phi, what type of comparison I performed here? Just look at, I compare 60 with phi, 50 with phi, 40 with phi, means every element you are performing comparison against phi. If every element you are performing comparison against phi, that is called sequential search friends. Okay. To find the location of phi, I applied sequential comparisons. As a result of applying sequential comparison, we are taking time complexities if array elements are already in the ascending order, right friends. Okay. So here we are having ascending order inversions are not there, it is taking n plus d value equal to 0, which is taking theta of n if array elements are already in the ascending order, right friends. Okay. Now what I am trying to say, internally we are applying sequential search algorithm for finding position. Now when it comes to applications point of view, they may ask the question, in order to find position of phi, we are applying sequential search. Instead of applying sequential search, if I apply binary search algorithm, then what is the time complexity of insertion sort algorithm? Are you getting points? Okay. Means they will ask the question, suppose general insertion sort algorithm, we are applying linear search. Instead of applying linear search, if you apply binary search algorithm, then what is the time complexity, and what is the like how many number of comparisons are performed and how many number of swappings are required. So that kind of study is required friends. Okay. That is application oriented study. Anyway, you are already having my notes. In my notes all these points already mentioned. Okay. So that is about, that's all about insertion sort algorithm friends. Okay. Quicksort algorithm, applications point of view median. Merge sort algorithm, application point of view inversions. Insertion sort algorithm, applications point of view, we can say instead of applying sequential search, we can apply binary search algorithm. Okay. Similarly, when you are talking about bubble sort algorithm friends, okay, bubble sort algorithm. In bubble sort algorithm, applications point of view, they are asking like this. First tell me what is a bubble sort friends. In bubble sort, after every pass, the largest element of unsorted part of the array will be placed in its proper place. Is it clear friends? So that is the object of bubble sort. For example friends, just look at here. Assume that is an array contains elements like 50 and then 40, 20, 30, 10. If you apply bubble sort algorithm friends, okay, in bubble sort algorithm, after every pass, the largest element of unsorted part of the array must be placed in the correct place. Okay. So suppose if you take pass number 1, the pass number 1, you are considering index like 1, 2, 3, 4, 5. Right friends. Whenever you consider pass number 1 in the algorithm point of view, this is called I equal to 1, outer loop, I equal to 1. Outer loop value I equal to 1. When I equal to 1, we are taking elements j starting from 1. Okay. So it is going up to j equal to 4. J equal to 3 and j equal to 4. Because if you have 5 elements, it will take only 4 comparisons. Okay, 4 comparisons. So when I equal to 1, it is taking j equal to 1. Now it is taking comparison between first element and second element. Okay, it means it is taking comparison like if a of j is greater than a of j plus 1. A of j greater than a of j plus 1. If this condition is true, we have to swap those two elements. Swap a of j, comma, a of j plus 1. You have to swap those two elements. So therefore, in this array, just observe friends, when j equal to 1, we are comparing these two elements. Just compare these two elements. So 50 greater than 40, yes. Then what I have to do? Swap those two elements, okay. So just swap those two elements, 40 and then 50. So j equal to 1 completed. Now when j equal to 2, apply this logic, a of j greater than a of j plus 1. So when j equal to 2, 50 greater than 20, yes. If it is yes, you can interchange these two elements. It is 20 and it is 50. Right friends. Afterwards, 50 greater than 30, yes. 50 greater than 30 means interchange these two elements, 30 and then 50. Now when j equal to 4, 50 greater than 10, yes, interchange these two elements, 10 and then 50. Now first pass is completed. After first pass, verify, have you placed largest element in the proper place or not? Yes. So in bubble sort algorithm, in first pass, largest element is placed in the proper place. Second pass, second largest element placed in the proper place. Like that, we need to take n minus 1 passes. Remember, if there are n elements, if you already sorted n minus 1 elements, automatically nth element is sorted, friends. Okay. So this is the way how exactly bubble sort algorithm is working. Then applications point of view, what type of application they will ask in bubble sort? So just observe friends, applications point of view, what type of question they will ask? Suppose they will provide an array. Array contains certain number of elements, and the time complexity for finding two elements x comma y from the array of n elements such that x plus y greater than 100. X plus y greater than 100. So this is one of the important application in bubble sort algorithm. Clear friends? So there is an array of n elements and we want to find two elements x comma y such that x plus y greater than 100 or not. Means we want to examine this statement, okay. The time complexity of finding two elements x comma y from the array of n elements such that x plus y greater than 100 or not. Then how to find this one, friends? Very simple. You can apply first pass of bubble sort. After first pass of bubble sort, you will get first largest element. This is a first largest element. After first pass of bubble sort, you will get first largest element. This is the first largest element. Assume that this first largest element is equal to x. But to find first largest element, how many comparisons you performed here? 1, 2, 3, 4 comparisons. If 5 elements are there, 4 comparison. 10 elements are there, 9 comparison. N elements are there, n minus 1 comparisons. Therefore, for finding this x, it is taking n minus 1 comparisons. I am ignoring swappings here. Swapping also n minus 1 only. So I am ignoring. If you want, you can consider also. Okay. Suppose comparisons are n minus 1. Swappings also n minus 1. Comparisons are n minus 1. Swappings also n minus 1. Afterwards, friends, go to second pass. When you apply second pass, you will get second largest element. First largest element is 50. What about second largest element? Second largest element is 40. You will get second largest element, you can say y. So therefore, y requires n minus 2 comparisons and n minus 2 swappings. Let me focus once again here, friends. Suppose if there are 5 elements are there, to find first largest element, we need 4 comparison. First, second, third, 4. In the worst case, every comparison may need swapping. That's why n minus 1 comparisons, n minus 1 swappings required. Afterwards, you are getting first largest element. Next, apply second time bubble sort algorithm. When you apply second pass, you will get second largest element, you can say y. Second pass will take n minus 2 comparisons and n minus 2 passing swappings. Then you can stop the process, you no need to continue it. Therefore, you got first largest element and you got second largest element. Now use this statement. Is this statement x plus y greater than 100 or not? You can verify it. If it is true, we can say we successfully found two elements whose sum is greater than 100. For example, friends, here who is the first largest in this array? 50. Who is the second largest? 40. 50 plus 40, 90. 90 greater than 100. Condition false. It means that first largest sum and second largest sum, first largest, second largest sum is not exceeding 100. It means that in that array, I cannot find two elements x comma y such that x plus y greater than 100. You observe logic, friends, okay? You are taking first largest is x, second largest is y. If the first largest and second largest sum is not exceeding 100, how can I say remaining element sum is exceeding 100? No, right? So therefore, after finding x and y, verify this condition. If this condition says that true, then we found successfully with the time complexity simply theta of or order of n, okay? The time complexity with order of n. Why it is order of n? Just observe, friends. Here n, it is n, 2n, 3n, 4n. 4n minus some constant. There is no importance of the constant, therefore I am taking theta of n or order of n. Direct answer, okay? It is taking 4n minus some constant. There is no importance of constant, that's why I am taking order of n. So this is application for bubble sort. Similarly, for selection sort also same application is there. But the object of selection sort, friends, after every pass, the smallest element is placed in the correct place. In quick sort, after every pass, pivot element is placed in the correct place. In insertion sort, after every pass, selected key element placed in the correct place. In bubble sort, after every pass, largest element is placed in the correct place. In selection sort, after every pass, smallest element is placed in the correct place. If it is smallest element, they may ask the question, the time complexity for finding two elements x comma y from the array of n elements such that x plus y less than 100. X plus y less than 100. Because selection sort is taking smallest element, right? That is the reason apply first pass, second pass. You will get first smallest element and second smallest element. If first smallest and second smallest is not less than 100 and we cannot find remaining elements whose values are sum is less than 100, friends, okay? So these are applications of sorting algorithms. Like that heap tree also most important topic, you have to go through heap tree, friends, okay? Right. So here I gave summary about sorting algorithms, right? Okay. We need to study all those algorithms. When it comes to spanning tree, friends, you need to focus on Kruskal's algorithm and then Prim's algorithm. Kruskal's algorithm and then Prim's algorithm. In Kruskal's algorithm, the simple logic, friends, edge weights must be included in the increasing order of their weights. Is it clear? Kruskal's algorithm, simple statement. If you want to form a spanning tree, edge weights must be included in the increasing order of their weights. But while including, you do not form any cycle. That is called Kruskal's algorithm. For example, friends, just let me take simple example. So let us consider a graph having weights are 2, 1, 1, 2, 1, let be 1, 2, 1, 1. Just assume that these are weights, friends. Okay, you can consider this something like 10 also. 10. In Kruskal's algorithm, the first important point is we need to select edges in the increasing order of their weights. I cannot use the word is increasing order because sometimes two edges may have same weight. That's why I can say it is non-decreasing order. Okay, non-decreasing order, friends. Okay, in Kruskal's algorithm, edge weights must be included in the non-decreasing order. In that case, if you apply that algorithm, obviously first weight is minimum weight. I can select this edge 1, then I can select second minimum, right? Second minimum. I can select this one third minimum, right, friends? Third minimum. After second take fourth minimum. It is a fifth minimum. Total 5 edges are completed. But actually, how many edges you need to include, friends? In spanning tree, if the graph G is equals to V comma E, in this spanning tree to include how many edges means number of edges must be equal to number of vertices minus 1. These many edges we need to include. Okay. So therefore, total vertices here if we consider 1, 2, 3, 4, 5, 6, 7. Right, friends, 7. So therefore, in that case, total number of edges required equal to 7 minus 1, 6 edges are required. Okay. Total number of edges must be 7 minus 1, that equal to 6 edges are required. Because vertices are 7, so 6 edges are required. So out of 6 edges, how many I already drawn here? 1, 2, 3, 4, 5. One more edge is required. So that edge is compulsory 10, friends. Do you know why I am taking 10? According to Kruskal's algorithm, we need to select minimum weightage, right? The minimum weightage, for example, if I select 2, it is forming cycle with the existing dotted lines. So even though it is a minimum, I cannot take because it is forming cycle. Let me take this 2. Still it is forming cycle. Let me take this 2. It is also forming cycle. So therefore, next minimum weight is 10 only, right? That's why I am choosing 10. Not only that, friends, it is compulsory you have to choose 10. Otherwise, the tree may be disconnected. Okay, but a tree never disconnected. Tree definition is, first of all, it should be connected and there is no cycle. A acyclic graph which is connected is called tree. Is it clear, friends? Okay. So therefore, this is a way you can answer question by using Kruskal's algorithm. One way of asking question is, they may ask, they will provide diagram, they will also ask the question like this: number of minimum cost spanning trees for the graph. Okay, number of minimum cost spanning trees for the graph. They will provide graph, they will ask number of minimum cost spanning trees. In that case also you can apply Kruskal's algorithm. Okay, how to apply? First look at, friends, I am taking first minimum, it is second minimum, it is third minimum. Fourth minimum I cannot take this because it is forming cycle. So fourth minimum, this is a fourth minimum and it is a fifth minimum and obviously sixth minimum. So in this problem I will get only one minimum cost spanning tree. I will get only one minimum cost spanning tree in this problem. Okay, only one minimum cost spanning tree. Is it clear, friends? I cannot get more than one minimum cost spanning trees. For example, if I draw one more tree so that you can understand how to get multiple minimum cost spanning trees. Let us consider, friends, whose weight is 1. Here it is 2, it is 1, let it be 1 and then 2. Let me remove some edges so that it is easy to understand. Okay. So here it is 1, 1, let it be 1. Here it can take it as something like 20. I want to find minimum cost, how many number of minimum cost spanning trees are there for this graph. Right. First important point is you have to check how many vertices are there in the graph. Number of vertices are 1, 2, 3, 4, 5, 6, 7. 7 vertices are there in the graph, friends. Okay. if the graph contains 7 vertices, your spanning tree contain 7 minus 1, that equal to 6 edges. Your spanning tree must contain 6 edges. Therefore, you can apply Kruskal's algorithm for drawing edges. Okay. Kruskal's algorithm always says that edge weights must be included in increasing order. In that case, here I can choose 1. Here I can choose 1 minimum weight. But observe friends, all edge weights are same only, right? Therefore, I can choose any one of them, any two out of these 3 edges, right friends? Okay. So either I can choose this one and this one, first one, or second one, or I can say third one. So therefore, out of 3 edges, I can choose 2 edges, right friends? Out of 3 edges, I can choose 2 edges. 2 object combination out of 3 edges. How many ways? That equals to 3 ways, right friends? Okay. Followed by this edge is compulsory. Why it is compulsory? Because spanning tree must be connected. That's why this edge must be compulsory, friends. Okay. But anyway, I will include this edge afterwards. So far 2 edges are completed. Out of 3 edges, I am choosing 2 edges. But how many edges are required? 6 edges are required. So 4 more edges we need to select. 4 more edges means I can choose this edge 1. It is second edge. It is third edge, friends. Right? Third edge. After selecting third edge, is it necessary to take this edge? No. If I take this one, it is forming cycle. Can I take this edge? No. It is forming cycle. Then only alternative is here I can take this edge. Therefore, this is only one way for selection of these edges. So 1 into 3C2 will get result equals to 3 spanning trees, friends. Okay. 3 minimum cost spanning trees. 3 minimum cost spanning trees will get here. So like that you can practice Prim's algorithm also. Okay. You can practice Prim's algorithm also. Next, shortest heap tree point of view, friends. There are some operations like find operation, finding max element from the max heap, min element from the min heap, right friends? Build max heap algorithm, and finding particular kth smallest element from the min heap, kth largest element from the min heap, max heap. So like that we need to find all operations, all find operations on the heap tree, friends. Okay. The shortest path algorithm's point of view, you will focus only on time complexity based questions like Dijkstra shortest path algorithm time complexity, Bellman-Ford time complexity, all pairs shortest path time complexity, BFS algorithm time complexity, right friends? Okay. Next, here simple loop, nested loop and recursive algorithm, mainly focus on recursive algorithm by taking master theorem topic, friends. Okay, master theorem topic. And these are direct questions, greedy method. You have to practice job sequencing, optimal pattern, Huffman coding and NAPSA problem, and also focus on matrix chain multiplication, friends. Okay. So I wish you all the best for everyone. I hope everyone of you having my notes. So therefore, you can go through the notes. Definitely, you will get same question. My suggestion is, friends, you give high priority to PYQ questions. If you see all ISRO questions directly came from 1 mark questions of GATE examination. Therefore, you prepare 1 mark questions as well as 2 marks questions properties. For example, if you observe 2 marks question, they are asking which of the following statement is true. Then out of 4, 3 statements are true, right? They are property based questions. You have to remember those 3 statements also. So 1 mark questions compulsory you have to prepare, and from the 2 marks questions you can select property based questions. Is it clear, friends? Okay. So that is a preparation strategy for our algorithm subject, and I wish you all the best. Thanks for giving the opportunity, friends.